So basically, I stopped last time at the question. So what's stopping us from basically accessing a value in the class directly and like setting it directly instead of going over getters and setters? Well, in object-oriented programming, oftentimes, it's actually practice of object-oriented programming to define all variables that are used in the class as private, because the person who uses the class shouldn't know what's going on inside the class, and they should be just working with the methods and not the variables themselves. So now we're going to define all of wherever you see real and image, the imaginary parts, as private, which is done with the 2 underscores in front of the name. So we're just going to add those 2 underscores in front of every time we see real and image. So we're defining each wherever you ever see it as private. So these variables are private now. Let me just check. Here we go. Alright, so I believe everything is good here. Let me just do one last check. So self-real, private, return self-real, self-image, self equals val. Alright, everything is good to go. So in object-oriented programming, everything is private. So, and then we're going to add 2 more things to this. We're going to add some restrictions. So we don't want the case where the user inputs something that isn't of the type int or float. So we're going to say in our setters, we're going to say not in int or float. We're going to say raise the exception. And it's going to say real part must be a number. And then we're also going to do the same thing for the imaginary part. There we go. There we go. And now we're just going to change this to image. Alright. So here we have these restrictions. Now we're going to check for this, so let's erase this. We're going to do try and accept. So let's write this out. So we're going to say c.setReal, and here we go. We're using a sequence this time, and then we're going to say accept. Accept exception, and then we're going to say as e, and then here we go, print e. As you can see, this actually worked. So, and it's also so this is how we should be doing things in object-oriented programming. So define your variables as private, and be sure to have restrictions on what can be input. So, and we're also going to do the same thing for, as you can see, we can't access private values because when you make it private, they can't be accessed outside and they're treated as non-existent. So C basically doesn't have this because it's private. And that's pretty much for that example. So let's move on to the next example to help illustrate how to properly use OOP mechanisms. So we're going to introduce some other methods into our examples. So let's delete this. We have all this from before, and now we're going to use imported module. We're going to use the math. So here we go. Let's make some more. Methods. So what these methods are going to do, they're basically going to define the polar form of given complex numbers. So let's define some excuse me. So we have get real, set real, and then we're going to have before sets, the setters, we're going to have define. We're going to say they're going to be called get fee. So we have get fee, and then we're going to also have define. We're also going to have oops, I should have said before that to be more organized. So we're going to have def modulus. So it's going to be called define. We're going to call it get modulus. Have the argument self. Alright, let's type this out. So what these do, get modulus is going to return, so we're going to do math, we're using modules here, square root. So square root, we're accessing self get real times self dot get real, and then I want to do plus self dot get image times self dot get image. So this is going to solve the modulus of this part. So here we go. That's that. Pretty long, but this is just an example. So as you can see, I'm basically making methods that will be used to simulate the complex number. So in whatever you're doing with the class, you have methods that have attributes and you have methods that reflect the actual real-life applications of your object or your class, of the class itself. So now we're going to do fee, and then return. We're going to have return math dot a10 of 2 of self dot get image colon, and then we're going to have, so we're getting the tangent 2 of the following. So self get real, and there we go. So let's actually clean this up a little, make it more readable. So it's also good practice to make things more readable, have like a space between each method or function, whatever you call it. And there you go. Alright, and so now it should work. So let's do the following. We're going to define complex. Here we go. Complex. So
-3 and 4. There's our instance of the class. Print. And then now we're going to do C, get. See, we have all kinds of functions now. So we have get modulus. And then we also have C.get fee. Don't forget your parentheses. And there we go. Those are our answers. So we define the polar form of the given complex numbers. It should be noted here that we can call a method from another method. That is what we did in methods get modules and get fee. We called getters real and imaginary of the real imaginary components. So we used other methods inside one method so we can use them within each other. So knowing this, we can have the following constructor. So instead of having this from before, we have the following. So we have, you can erase this, and we could say self dot set real, and we have self dot set image, and then we have image. And there we go. So basically, we went from what we did doing it directly, like this. Hold on, let me just erase all this. Instead of having it look like this and directly doing it, we can do the following. We basically use the method to set these values in the initialization of an instance. And that's pretty much it for the example. We hope to see you next time.